Next, we have Amazon Comprehend, a natural language processing and text analytics service which uses machine learning to find insights and relationships in text. So, this service can identify critical elements in the data, including language, people, places, and it can even categorize text files according to the topic. You can use it real time to automatically detect customer sentiment in your content, may it be your social media post, product reviews, or phone transcriptions. It also locates any content that contains personally identifiable information, so you can use it to anonymize the data and remove personal information from the data. As Amazon Comprehend is fully managed, you can just run it quickly without having to train models from scratch. You can uncover meaning and relationships in the text from customer support tickets, product reviews on your website, social media feeds, blogs, documents, or other resources. It can easily tell you which service is the most discussed one and what is the sentiment. And if you have a large website or a large collection of books or a large collection of documents related to insurance, health, legal documents, whatever, and you want to categorize them and put them in separate folders or separate files, or you want to suggest your content to the readers in more personalized way, you can use Amazon Comprehend to identify topics in the documents automatically and then sort them out. Amazon Comprehend can be easily extended to identify specific terms, such as policy numbers, part codes, or medical terms, in whatever way that makes sense to your business. And you can add this customization without any machine learning experience. Amazon Comprehend also offers Amazon Comprehend Medical, which understands and accurately identifies complex medical information. It also provides context that whether a patient has tested positive or negative to make the extracted term meaningful. Let's try Amazon Comprehend and see how it works. So you can use Amazon Comprehend for real-time analysis in two ways. First is real-time analysis with built-in models, or you can use custom models for real-time analysis. So there is a default input text. Let's analyze that text. So with entities, you can detect references to the names of people, places, and items. It can even reference to dates and quantities. As we can see, here is a person entity, organization, other, quantity, date, location, and then again organization. Next, we have key phrases. So basically, a key phrase is a string containing a noun phrase that describes a particular thing. And generally, it consists of a noun and the modifiers. Each key phrase includes a score as well that indicates the level of confidence that Amazon Comprehend thinks it's a noun phrase. You can use the score to determine if the detection has high enough confidence for your application. Next is language. So it has 0.99 confidence that the language is English. And if your text is multi-language, it will examine the text to determine the dominant language. Then we have personally identifiable information. So this time it will analyze the document to find out if there is any personal data that can be used to identify an individual. May it be an address, account number, or phone number. So this type of analysis provides two modes. One is offsets, that where the location of PII in your text document, or you can label text document with your PII. So if we label, we can get the following label: date, time, email, address, or phones. But if we want to identify the location of PIIs, then we can go for offsets. So it tells us that this entity is name and it is personal identifiable information. This may be a credit debit card number. This may be a bank account number, or there may be an address or phone numbers. And again, if you have a large document, the sentiment will determine the dominant sentiment of the text. So the sentiment says it is 0.98% neutral. We can also analyze the syntax in the text. So basically, it will parse the words in the text and show the speech syntax for each word. And you can then understand the content of the document. So hello is interjection and the name is proper noun, your is a pronoun, and any company is also proper noun. You can also get these insights in terms of an API call and response. If you call the detect syntax API, the syntax would be two fields. One is text and the other one is language. An API response would contain syntax tokens in the form of a dictionary with token ID, text, begin offset, and offset part of speech, and the confidence score. For this demo, we use the text in the input text field. But obviously, this is not feasible if we have a lot of documents. We cannot copy paste the text here. In that case, we can run the analysis jobs. So you can create an analysis job by naming it, defining the analysis type, and also the language. If you want offsets or redirections, then you also have to specify your source. If you have your documents, you must have them in S3 location and then choose your input format. You can choose one document per file or you can say there is one document per line. Amazon Comprehend will perform all the analysis and output data will be stored in an S3 location. You can also set access permissions from here. Let's take a look at Amazon Kendra. So Amazon Kendra is basically a search service which is powered by machine learning. It uses deep learning models to overcome the flaws in traditional search methods. It does not use keyword matching and ranking, rather, it uses natural language. So with Amazon Kendra, you can go through your unstructured data and scattered information and find the right answer to your question. Since it is a fully managed service, you do not need prior machine learning or deep learning experience to use Amazon Kendra. For the exam, it's enough to know the capabilities of Amazon Kendra and use cases where it can help you. So how Amazon Kendra works, it creates an index where you will add your data sources. You can use multiple sources like file systems, websites, Dropbox, Salesforce, SharePoint, S3, and many more as your data source. Once you add a data source, Amazon Kendra will crawl through all the documents, all the information, and then index them. So it will take some time. After the indexing part, you can test and then deploy your Amazon Kendra service. You can connect Amazon Kendra to an end application such as a React application as well. Some benefits Amazon Kendra have over traditional search methods that it does not use keyword matching and ranking, rather it understands the context of the question, which is very important, and it also understands natural language, so you can ask questions such as how do I connect my Wi-Fi, how do I register myself on your website, so you can ask questions in natural language. And more importantly, Amazon Kendra improves automatically over time. And you can actually retrain the deep learning models that are powering Amazon Kendra on your own particular data sources. For the exam, it's better to look at real use cases where companies are using Amazon Kendra. So let's take a look at a few of these in our next browser window. So 3M is a Minnesota-based multinational corporation that produces medical products. And their scientists, while filing for patents or doing new research, need access to prior relevant research. So they use Amazon Kendra to gather past information. And then there is PwC. PwC is developing a system with Amazon Kendra that helps users find the results of past surveys and find the results from the past documents by asking questions in natural language. So CityBot is a Q&A chatbot built with Amazon Lex and powered with Amazon Kendra. So CityBot uses Amazon Lex and Amazon Kendra for their Q&A chatbot. Residents can ask questions about taxes, licenses, registrations, health services, and It uses Amazon Kendra to find the relevant information from state websites. Also, Oklahoma State University is using Amazon Kendra to provide all the information to newcomers about their programs, their fee structures, their scholarships, and everything. Let's go back to our Amazon Kendra homepage in our AWS console and create an index and add data sources by clicking the orange button at the right side. Let's give it a name as my index. It does not accept underscore, but it accepts hyphen. Description is optional. You can skip it. So you can also log your Amazon Kendra service into Amazon CloudWatch to keep an eye on the errors and the usage. Next step is to select an IAM role. We can select an existing IAM role or create a new one specifically for our Amazon Kendra. So for now, we will create a new role and it automatically gives a name to this new role. There is an option to use your own encryption key or the Amazon's. Then there are access control settings. For now, we will use the default settings. There are provisioning additions. You can use developer edition or enterprise edition. So with developer edition, you have 10,000 documents to be added as data source. You have 4,000 queries per day and runs in only one available zone. So for the purpose of this demo, we are going to use developer edition. So our index has been created. It's time to add data sources. So we will add data sources by clicking this orange button. For the testing purpose, AWS provides us a sample dataset as well. We can use it for this demo. So this dataset is basically made up from AWS documentation. We can name it as my data. There are sample queries you can test with this dataset, just so you do not have to read the documents and know if it's providing same information or not. So you can ask, how do I SSH into my EC2 instance? What is an EBS? See, these are natural language questions. Now, the data set will take some time to sink in as the Amazon Kendra has to crawl through all the data and then create index. Meanwhile, you can look at the data source details here. So at the left navigation pane, we can see enrichments, synonyms, and query suggestions. So basically, you can add synonyms to your index to make it easier to find information in your documents that are related to your specific domain. Sometimes specialized terms that are used in a specific domain have different meaning in general or traditional English, so you can use synonyms here to support natural language processing. For example, an EC2 can also be called Elastic Compute Cloud. You should not use synonyms in case of generic English language because these are already fed into your Amazon Kendra. We also have query suggestions here in Amazon Kendra. Query suggestions make typing search queries faster for your users and helps guide their research. So you can suggest all the popular queries that are fulfilling some criteria, or you can feed your own queries. For example, if upcoming events 2021 was the most searched query, then when the user starts typing up, you can suggest upcoming events. So this way you can save time for your users. Let's click on the search console, the last item in our left navigation pane, to see how it works. So here we can ask queries. Let's enter a test query. I just wrote EBS, so it will go through all the documents and then provide us relevant answers. So basically, the results contains EBS in all the documents. Let's ask a question in natural language. What is an EBS? So it tells us these are multiple volumes that can be attached to an instance. That's better. You can also sort the results by relevance. Let's go back to my index from the navigation menu and delete all the resources we have used for this demo to avoid heavy charges. Since we do not have any of these issues, we will just click on just curious, no real use case. The deleting process will also take some time. Next in line, we have Amazon Transcribe, an automatic speech recognition service. It is nearly impossible for computers to analyze audio data, extract the sentiment from audio data, or extract the meaningful key phrases from the audio data, or answer questions asked in audio. Therefore, we need a process to convert recorded speech into the text. And historically, this was done by transcription providers, and they would sign a pretty expensive agreement with you, and the quality was also low. With the advent of deep learning, we have automatic speech recognition techniques to convert speech to text quickly and accurately. Amazon Transcribe also uses automatic speech recognition models to transcribe customer service calls, automate subtitling, and generate metadata for media assets to create a fully searchable archive. It also provides us specifically Amazon Transcribe Medical to convert medical speech to text. Some features and benefits we can get with Amazon Transcribe can be easy to read transcriptions. Since it is using deep learning, it can easily add punctuation and formatting as well, which makes it easily readable. And we don't have to add the punctuation manually. While running Amazon Transcribe, we can instruct it to identify and redact sensitive personally identifiable information from the spotted language transcripts. So this allows us to easily review and share the transcripts for customer experience insight and agent training. It can also work with streams or audio in batches or in real time. So if you have a live audio stream, you can pass it to Amazon Transcribe and get the text in real time. Since Amazon Transcribe returns a timestamp for each word, this is an easy way to add subtitles to the video or find a word or phrase in the video recording. Since Amazon Transcribe can return a timestamp for each word, it makes it easier for us to add subtitles to our video or find a specific word in the original recording. And if you think that your audios are more domain specific, such as they belong to a deep learning arena, or they are from the medical side, or they are specifically from the car manufacturing industry, so you can add new words to the base vocabulary. This way, you can generate more accurate transcriptions which can identify domain specific words. Long phone calls can have multiple speakers, or the meeting recordings can also have multiple speakers. And sometimes we want to know who spoke that. So, Amazon Transcribe can automatically recognize the speaker change and attribute in the text to capture scenarios like this. You can also use Amazon Transcribe to get a list of offensive words or a list of specific words so that you can remove that from the files. Some sample use cases where Amazon Transcribe can be used involve improving customer services. So, customer service information can provide us a lot of insights about the customer behavior, the call center staff behavior, or if their problem was solved or not, and what were their sentiments. So, Amazon Transcribe can help us in transcribing voice based interactions, and then we can use Amazon Comprehend to extract meaning and intent from those conversations. We can automate the process of video subtitling through Amazon Transcribe, which can save a lot of time and manpower. Since Amazon Transcribe can provide us a punctuated readable script, we can pass it to other services to get insights from that text. We can use Amazon Transcribe to catalog audio archives as we can catalog text archives. And in case of medical emergencies, we can use Amazon Transcribe Medical to easily extract the information from the physician and the patient conversation. And we can use that text to enter the patient record in the system easily. With Amazon Transcribe, we will pay only for what we use. And the charges are based on the seconds of audio transcribed per month. Let's get started with Amazon Transcribe. When we press the Start Streaming button, it asks us about the microphone permission and then it starts writing the transcription output. As we can see, it has already added the comma and the full stop, and the accuracy is pretty good. Let's see what are some additional settings we can have. So we can add a custom vocabulary which can improve the accuracy of recognizing words and phrases. We can also use vocabulary filters, and it can also help us identify speakers in the stream. But speaker identification is varying between languages. So we can use application integration or API to connect our application to Amazon Transcribe in real time. We can also create transcription jobs instead of live data streaming if we have a recording available. And we can choose specific language such as English, or we can choose automatic language identification. But the functionality is less for automatic language identification. Then we can browse to S3 and find our audio files that we need to get transcribed. If we have a multi-channel audio, we can get it into separate channels, or we can even identify speakers in the input audio if we want to. But for now, our sample audio contains only one speaker. So with the alternative results, we can get multiple results with a single audio, and we can choose the best one. But if this option is not enabled, AWS Transcribe will automatically choose the best transcription based on the confidence score. And if we want to remove information such as personally identifiable information, or we want to remove offensive words from our vocabulary in the recording, we can select these options. And we can also customize the job with custom vocabulary by providing specific words. So let's create the job. Once the job status is complete, we can click on the job and find out the details. So we have all the configuration of our job, then we have transcription preview. So when we move a cursor to a specific word, we can see the timestamp and the confidence. We can also see there is a lot of punctuation being added and it is readable now. We can also use APIs to automate and manage transcription jobs. So we will call the job with media file URI, and then we will get the response, and we will get the location of S3 object for the transcript. We can also delete the job in the end, otherwise the transcription will be expired in 89 days. Amazon Poly is another high-level AI ML services provided by AWS that can turn text into lifelike speech using deep learning models behind the scene. It uses very advanced deep learning techniques to sound like a human voice. It also provides a broad set of languages across which you can select different lifelike voices to use. So this way you can build speech-enabled applications for different countries. And if you want a custom voice for your organization, Amazon Poly's team can help you create a custom voice for exclusive use for your organization. And if you want a custom voice for your organization, Amazon Poly can also provide that. Like other AI ML services, Amazon Poly is also pay as you go. So you are charged based on the number of characters of text that you convert either to speech or to speech marks metadata. Some features which Amazon Poly can provide us are different natural sounding male and female voices, and it provides us a fluid pronunciation. Once you have converted a text into speech, you can reuse it many times, you can replay it many times without any additional charges. It also supports standard file formats such as PCM, MP3, OGG. You can either save them in cloud or you can use them locally. It also allows you to control different aspects of speech, so you can control the volume, you can control the speed rate or pitch, etc. So this way you can modify Amazon Poly according to your consumers or customers. It allows real-time streaming, so you just need to write your text, send it to Amazon Poly, and it will provide you the audio as a stream which you can play in your apps. There are different use cases where Amazon Poly can be used. So it can help attract different consumers onto your content creation apps or websites. When you have alternative ways to consume online content, you attract far too many visitors. And they will always come back because they have more fun this way. Suppose you want to convert a news article into audio. So you will extract the article from RSS feed, pass it to Amazon Poly through AWS Lambda. So Amazon Poly will respond with the audio back to AWS Lambda. And then AWS Lambda will store the audio in S3 from where you can use it anywhere. Amazon Poly is also useful in e-learning. So it can also enhance visual experience when you have speech along with the text. And for the new language learners, it is also very important to listen to correct speech. And with Amazon Poly, you can provide that. You can use Amazon Poly in your different exercises when you are teaching language learners. So they can highlight text in the app when they are listening to it. So this way their language learning ability increases. Amazon Poly can also be used in contact centers. Instead of real human agents, you can engage customers with natural sounding voices. You can also use it with Amazon Connect. Amazon Poly's API can deliver real-time information to your contact centers, such as service status, account status, billing information, or contact information. Now, let's try Amazon Poly. So we have this console interface. If we are not using the API, there is a drop down from where we can select a language. It is even providing the accents for different languages such as Spanish and British English, Indian English, US English, or Australian English. You can also choose a voice from a set of voices available. So let's play how Justin sounds like.
Hi, my name is Justin. I will read any text you type here.
So he seems like a little boy. We also have additional settings where we can set the file format. May it be MP3, OGG, PCM, or we can get speech marks as well. We can also decide the sample rate ourselves. You can also customize the pronunciation by providing lexicons. And in the console, you can only apply for 5 lexicons. Once you have all the settings and you think the sample is correct now, this is what you want, you can either save it to S3 or you can even download it. Let's talk about Amazon Rekognition, a deep learning based visual analysis service to search, verify, and organize millions of images and videos. Since it is a fully managed service, you don't need computer vision or deep learning expertise to take advantage of Rekognition. So Amazon Rekognition can perform wide range of tasks such as predicting custom labels, object and scene detection, image moderation, facial analysis, celebrity recognition, or video analysis, even PPE detection. Let's go towards some of the functionality and find out what can we do with custom labels. If your problem is unique and you want to find objects and scenes related to your business, you can use Amazon Rekognition custom labels. So it costs you $4 per hour for inference and $1 per hour for training. Pretty low cost. All you need to do is identify your business needs and create a list of custom labels. And you need to collect relevant images. Now, Amazon Rekognition will prepare the images by uploading them and labeling them. Then it will train a custom model automatically, evaluate the model, and if it needs to be improved, it will again improve the model. So it is an iterative process. Once the model is trained, you can use the API to get the predictions. Now, you can also provide feedback on the model predictions to tell if the model is predicting correct or wrong. So this way, you can retrain your AI model for better performance. Some use cases where you can use custom labels are finding the content more easily by automatically generating a relevant list of images and clips from thousands of images and videos. So this way you can identify specific game events. And the amazing part is You will get a visual interface that makes it easy to upload your images and label them. Now, let's go back to Amazon Rekognition and see what else it offers. So, there are multiple demos available for different tasks, such as object and scene detection. Either you can use these two images, or you can upload your own image, or you can find an image from the internet and use that image's URL. So, it has labeled, for example, it said there is a city, 99% chance, or town, it's an urban area, there are buildings, etc. And the buildings are high rise. Let's see what image moderation does. So, Amazon Rekognition can automatically detect explicit or suggestive adult content or the violent content and provides confidence scores. So, in this image, there were no moderation labels, but in the next image, it should moderate. And it has said that it is suggestive. Female is wearing swimwear or these are revealing clothes. So, it has moderated the content. Next, we have facial analysis. It looks like a face of a female. Age range is between 21 to 33. The face is smiling. The face seems to be happy. So it also identified the sentiment in the face. The face is wearing glasses. Eyes are open. Mouth is open. So this is pretty extensive analysis of the face. There are also example API request and response available to use it in your client application. We have celebrity recognition. So it is 100% confident that it's Jeff. It can also identify text in the images and get you the digital form of that text. See, it's also keeping the capital letters correct. So PPE detection in the age of COVID-19, an important feature. So we need to customize the PPEs. We can say face cover is needed, hand cover is needed, or head cover is needed. And what is the minimum confidence level? Now it says persons with required equipment are 4 and persons without required equipment are none, and there are no intermediate. It can also analyze videos. So let's play this example video and see. So it says there are humans, people, person, audience, crowd, speech, furniture, beard, or chair. We can also upload our own video. You can also analyze your Amazon Rekognition jobs or tasks on CloudWatch. Now that we have explored all the functionality in Amazon Rekognition, let's discuss common use cases where it can be used. So, in media, we can use Amazon Rekognition to automate different tasks such as detection of black frames, end credits, short changes, color bars. This way, we can reduce the time in video creation. AWS Rekognition can also help us in workplace safety by analyzing our images from on-premises cameras to detect if employees are wearing PPEs, etc. We can easily generate content for tourists to provide information about a certain landmark, its history, operating hours, ticket prices by simply taking a photo. In the days of internet, we can use AWS Rekognition to enable digital identity verification. So we can compare photos, a selfie with a document such as driver's license. So this way we can automate several tasks which require secure permissions. Next up, we have Amazon Personalize. It can increase customer retention by adding personalized recommendations powered by the past data of Amazon. So, you must have used Amazon to buy something, and you must be amazed at how they bring all the things you are interested in to their homepage and they suggest categories that you are particularly interested in. Sometimes, when you go for a specific product, they offer related products below, and you are just lost in the products. And you definitely buy some of those. Guess what? Same machine learning technology is available as a service that does not require any machine learning expertise. So, with Amazon Personalize, you just have to pass all your customer behavior data. Amazon Personalize will train machine learning models and evaluate and deploy them at scale. And you just have to connect your application through an API. So basically, when you pass all of your data from Amazon S3 towards Amazon Personalize, what it does is it loads the data, it will inspect your data, identify certain features, then select algorithms based on those features. It also automatically selects hyperparameters for these algorithms and then train the model according to these hyperparameters. It will again tune and optimize the models, then build a feature store that these features are good for this model. It will host the models and then create real-time predictions. Let's take a look at what it offers. It considers specific needs, preferences, and changing patterns of the buyers or users to improve engagement and retention. And these algorithms are tuned well enough to suggest new products and categories to new users, the users which have no past data. And it can even suggest content based on the time of the day and time of the year. And since Amazon has a vast amount of retail data, customer behavior data, and they have trained it on their own data, which is definitely very large, so this technology will automatically select the best algorithm based on your specific dataset. Amazon Personalize can integrate with existing applications, may it be SMS, email, website, or mobile app through Amazon Personalize API. It offers a long list of use cases in industries such as retail, media, and entertainment. Moreover, it keeps on learning new data and improves itself silently. Amazon Personalize offers a long list of use cases where it can solve the problems in the industries such as retail, media, and entertainment. Moreover, it keeps on learning new data and improve itself silently. So all of your data is encrypted to be private and secure, and it is only used to create recommendations for your customers. And even the data is not shared between customers or with Amazon.com. So to secure your data, you can also use AWS key management services, which enables you to maintain control over who can use your customer master keys. Some use cases where businesses can use Amazon involves improving their homepage as per the user. So let's not lie, everyone likes special treatment. And with Personalize, you can enable customers to find their desired product faster by also recommending relevant items. So it brings revenue to the business as cart size increases. Retargeting in marketing is the practice of sending targeted advertisement to the people who have already interacted with your website to make them come back. And Amazon Personalize is a great service to send personalized advertisement and messages to bring back customers. Large websites, such as video streaming websites, have a lot of video content, and user cannot scroll through all the content and find interesting ones. With Amazon Personalize, interesting content based on the user's history can be shown. Let's find out how Amazon Personalize helped Pulse Live improve fan experiences on their website. So basically, this website works with sports federations, media companies, and sponsors to deliver digital, social, and content solutions. And the highest concern their customers have is the fan engagement with the videos. But conventionally, all the fans saw the same list of recently published items. To personalize the fan experience, they have used Amazon Personalize. So all fast user interaction data is stored on S3. And they use Amazon CloudFront. Amazon CloudFront is a fast content delivery network service that securely delivers data, video applications, APIs to customers globally with low latency. So the user will interact with the content through CloudFront. All the user interactions will be tracked and stored into DynamoDB. Next time, whenever the user logs on, Amazon Personalize provides the ranking on the content according to the specific user and passes the information to the website through API gateway. DynamoDB also keeps the record of the videos where users are actively involved in suggested content to measure the success. By introducing this architecture, video consumption increased by 20%. With Amazon Personalize, different types of charges apply depending on the features that you are using. So you should review the pricing details before going ahead. Let's take a look how Amazon Personalize console looks. So let's create a dataset group that contains the datasets, solutions, and event ingestion API for the related solutions. Next, we have to create user item interaction data. So Amazon Personalized requires user item interaction data to create a solution. You should follow a specific format to create user item interaction data, as shown in the JSON at the right. You can either use an existing schema or you can create a new schema. Once you have created a schema, you can import user item interaction data and start working. So with your dataset group, you can upload datasets. You can install event ingestion SDK. You can create solutions and then launch campaigns. You can even create batch inference jobs here. Picking up another service from the pool of AWS services, we have Amazon Forecast, a fully managed service that uses machine learning to deliver highly accurate forecast. These days, resource planning, product demand planning, or financial performance is very important for businesses. So they either use simple spreadsheets or complex financial planning softwares. And these tools forecast by looking at a historical series of data, which is called time series data. For example, you can predict the future sales of a certain product by looking only at its previous sales data. And the assumption behind that is the future is determined by the past. But sometimes the trend is irregular and there are certain factors that impact the sale, such as holiday season, locality, or weather season. So, for the correct forecasting, it is important to consider these independent variables as well. And Amazon Forecast does that for us. Let's see how it works. Since Amazon Forecast is a fully managed service, it does not require any prior machine learning experience. You need to pass all the historical data and the related data. For example, you can say the demand for a particular color of a shirt may change with the seasons and store location. So you can pass the season information and the store location as well. And upload all of your data to Amazon Forecast. Amazon Forecast will automatically inspect the data, identifies the key attributes, and select right algorithms needed for forecasting. Then it can train and optimize your custom model. Once the model is trained, you can visualize the forecast in the console, or you can get a CSV file to use in your own application, or you can use an API to integrate it into your custom application. So Amazon Forecast uses the 20 years of experience from Amazon.com. It also includes AutoML capabilities that take care of the machine learning for you, since it has a large number of models and it picks the right model for your dataset. It can work with any historical time series data, may it be price, promotions, economic performance metrics. And you can also add associated data with your time series data, such as product features, floor replacement, store locations, to determine the complex relationships. This way, the accuracy is increased with Amazon Forecast. We can use Amazon Forecast for different types of plannings, such as product demand planning, financial planning, resource planning, web traffic planning, or transport planning as well. Let's find out the use cases where industries are using Amazon Forecast. So, a business in India is using Amazon Forecast to simultaneously manage in-stock availability of fresh produce while minimizing the wastage. So, another company is using Amazon Forecast to predict different insights such as churn prediction, customer lifetime value. They are also automating their marketing activities based on those insights. Another furniture rental company uses Amazon Forecast to predict the sales of their rental services, like how many customers might rent in the Bay Area or how many coffee tables customers might rent. So, this way, they have improved the accuracy by 20% compared to their existing forecasting algorithm. This means they can stock the right products at the right time and save on the purchase costs. Even the media industry is using Amazon Forecast to achieve their KPIs by keeping an eye on the trends of digital marketing channels and industries. Let's try Amazon forecast. We need to create a dataset group by defining its name and deciding the forecasting domain. Either you can use retail, inventory planning, EC2 capacity, workforce, web traffic, or metrics. But if your problem is not related to any of these, you can choose custom. Once you have created your dataset group, you can define your dataset name. You can choose the frequency of your data. The frequency is at which entries are registered into your data file. It can be minutes, hours, days, weeks, month, and year. Remember that your dataset should hold enough historical data for the AWS forecast to process. Then we need a data schema. We can either use a schema builder or a JSON schema. So we need an ID, we need a timestamp value with a specific format, and we need a target value. So timestamp format could be with minutes or without minutes. Next, we need to import our dataset from S3. So the S3 file should contain all of these attributes in order with the specific format, and the file name should contain at least one alphabet. Once your dataset has been imported, you can choose a machine learning model. If you are unsure of which model to use, you can choose AutoML. Otherwise, it provides multiple state-of-the-art models such as ARIMA or DPAR. You can also add weather indexing, holiday featureization, or multiple independent variables with your dataset. Next up, we have Amazon Textract, a machine learning service that can easily extract text and data from the documents. So, in many companies nowadays, plenty of valuable business data resides in the documents, and this data is the heart of this digital transformation age. But 70 to 80% of this data is embedded in unstructured formats, may it be invoices, emails, receipts, PDF documents, and many more. So, to digitize these documents and make the most out of information from these documents, companies now require an AI based service that can do it automatically instead of relying on manpower. So, that is why Amazon Textract is an important service. So, Amazon Textract goes beyond simple optical character recognition to also identify the contents of the fields in the forms and information stored in the tables. And it can convert different type of documents into an editable or digital format. Consider you have hard copies of a lot of forms and you want to store all the vital information from them on the spreadsheet. So usually this is the task done by the data entry operators, but it is time consuming, hectic, and error prone. So by using Textract, we can upload all of our forms, and then in turn, this Textract will return all the text, forms, key value pairs, tables in the document in a more structured and sophisticated way. Textract can also identify handwritten text in the image. So this makes information extraction more useful because handwriting extraction is more complicated than digital writing as handwriting styles varies from person to person. So how Amazon Textract works? So it requires scanned documents. These can be balance sheets, text forms, insurance claims, or medical notes or credit applications. Then Amazon Textract will extract text fields of interest and tables from the forms. Extracted data with confidence score is passed to Amazon Augmented AI. So by using Amazon Augmented AI, either a human can review the low confidence. By using Amazon Augmented AI, high confidence predictions are immediately returned to the client application, while a human reviews the low confidence predictions and provide feedback. And the results are stored to S3 and then passed to client application. So the basic features provided by Amazon Extract are key value pair extraction. So it enables you to detect key value pairs in the document images automatically. So you can then retain the context of the document without manual intervention. It can also preserve the composition of data stored in the tables during extraction. So this is helpful when our documents are structured. They can be financial reports, they can be ledgers, medical records, etc. So it preserves the coordinates of each piece of the identified data. So if we want to know where a word or number came from, we can easily find its location. This feature of Amazon Textract is also useful for search systems, since it provides confidence scores on each of the prediction. This helps us in more informed decision about the result. Let's try Amazon Extract. We have this sample document to test Amazon Textract. We can also upload our own document. Remember that Amazon Textract demo accepts documents with fewer than 11 pages, so that are smaller than 5 MB. But if you use Amazon Textract API, it will accept larger documents with larger page counts. So now in the raw text, Amazon Extract can extract lines and words from the document. And there are bounding boxes around the words as well. But when we want lines from the raw text, the bounding boxes are around the lines. So it also provides localization in the text. Then we want to know if there are any forms in the document. So we can see there is a form about full name, phone number, home address, and mailing address. Then if there are any tables in the document, so it has extracted the table and it has also preserved the composition of the table, which is a useful feature for structured data. Then if we want human review, we can use Amazon Augmented AI here. And we can easily see that there is handwritten text written in this employment application, and Amazon Textract successfully read that text as well. So we just learned that it is an easy to use AWS service. So we can store the extracted document information with Amazon DynamoDB or S3. So Amazon Comprehend is definitely very useful, but if there are multiple custom data fields that you want to extract, Amazon Textract may not be the solution. Because sometimes you want to extract invoice IDs from all the invoices. In this type of problem, Amazon Textract doesn't work for us. In table extraction, Amazon Textract doesn't allow you to define table headers. Instead, it names the columns itself. Therefore, it is not easy to search for a particular column in a table. For now, Amazon Textract only supports English, Spanish, German, Italian, French, and Portuguese text extraction. It does not work on other languages. Unlike other AWS ML services, Amazon Textract doesn't allow you to fine-tune it on your own data. So you can fine-tune Amazon Kendra, you can fine-tune Amazon Comprehend on your own data, but to increase the Amazon Textract efficiency, you need to add a human operator in the process. So human operator can review the extracted information from Amazon Textract and annotate the wrong values. So we have already discussed many AI ML services provided by Amazon in the previous videos. Now we will shortly cover what Amazon Panorama, Fraud Detection, and Amazon Lex do. So AWS Panorama. It is a machine learning appliance and an SDK which allows us to bring computer vision into on-premises cameras for local predictions. So we don't have to connect our cameras to the cloud, send the streaming videos in, and get the predictions from the cloud, where our machine learning models are residing. Instead, with Amazon Panorama, we can easily install computer vision system in our camera locally. And this will work with or without internet as well. So we can automate human review process to identify potential issues with Amazon Panorama. Now, our camera can use computer vision to evaluate manufacturing quality. It can also identify problems and bottlenecks in industrial processes, and it can even monitor workspace security and safety. So basically, it is a hardware device that allows you to add computer vision to your Internet Protocol cameras. Originally, the cameras weren't built to accommodate computer vision. And with Amazon Panorama, you can turn your existing cameras into smart cameras. So, with Amazon Panorama, you can reimagine your retail business as well. You can use Amazon Panorama to count customers in a shopping mall. You can generate heat maps, get the timings when most customers are in. And you can do all this without updating your existing on site cameras. Amazon Fraud Detector, another machine learning service provided by AWS, which is fully managed. So, Amazon incorporated its 20 years of fraud detection expertise into this Amazon Fraud Detector service. So, businesses can use Amazon Fraud Detector to catch online fraud faster. Currently, many fraud detector models are generalized to every problem. But Amazon Fraud Detector can customize each model it creates to a customer's own dataset. This way, the accuracy of this model is higher than one size fits all ML solutions. With just few clicks, it can prevent and detect online fraud by accurately picking from legitimate and susceptible accounts. So, it can immediately detect fraudulent signups by keeping an eye on all the traffic. So, it can also flag suspicious online payment transactions even before processing payments and fulfilling orders. So, you can set up your checkout flow to evaluate new orders and ignore the suspicious ones for review prior to processing payments. It can even identify fraudsters among customers or users with very little data, such as an email or IP address, without any past transactional history. It can also keep an eye on the customers if they are abusing online services. To set up Amazon Fraud Detector, you only have to upload a CSV file with all of your historical online event data to Amazon S3. Then Amazon Fraud Detection will build a fraud detection machine learning model that is specifically customized to your own data with just few clicks. Basically, it will select multiple algorithms, train them and optimize them and validate them, choose the best one and host that model. You can also add multiple decision rules into your Amazon Fraud Detector logic to turn your model scores into actionable outcomes, such as you can say at which criteria the transaction or the event should be reviewed. Amazon Fraud Detector can provide a prediction API as well for real-time fraud detection in client applications. Next, we have Amazon Lex, a conversational AI for chatbots. So, we can use Amazon Lex for building conversational interfaces into any application that can use voice and text input. Amazon Lex provides the advanced deep learning functionalities to introduce automatic speech recognition for converting speech to text. It can also recognize the intent of the text to enable you to build applications with highly engaging user experiences. After receiving the text input or converting speech to text, it can use natural language processing to recognize text intentions. And we all know about the success of Amazon Alexa. So we can integrate the same technology in our application by using Amazon Lex, which can enable us to build sophisticated conversational chatbots. So, Amazon Lex can help us build bots to increase contact center productivity. We can increase and automate simple tasks. Like other fully managed services by AWS, Amazon Lex can also scale automatically. So, we don't have to worry about managing infrastructure. The chatbots built using Amazon Lex can run anywhere, including mobile phones, web apps, or chat services such as Facebook Messenger, Slack, or Twilio SMS. If we add Amazon Lex in our call centers, callers can easily perform simpler tasks such as changing a password, requesting a balance on an account, without needing to speak to an agent. So, this way, the call center staff can focus on more complex problems. We can also create Q&A bots for our FAQ pages or informational bots such as historical information, traveling information, or legal information with Amazon Lex. From the exam point of view, it's good to take a look at a few case studies on businesses that use AWS AI ML services to solve their problems. Let's take an example of scam calls. So it's a real thing nowadays, and people have been scamming others successfully. There are multiple cases of fraud in several countries which made their way to the international news as well. And some of these scam calls may include threatening calls from agencies, technical support calls, call asking for your website password, or asking for your bank details or health insurance. Scammers also use family to scam the public. So, in order to deploy a call fraud detection system using AWS services, first of all, we use an API gateway to get all the metadata related to the call. We need to have some data from the past year to train a model that can detect fraud calls. We use API gateway and Lambda functions to pass the data to S3, and the encrypted mirror of the call is stored in SQS, then eventually to S3. And SageMaker is used to train a model using the data from S3. So the model is trained with multiple iterations and then tested. When the model is good enough, the performance is good enough, the model is deployed with SageMaker endpoint. Endpoint will serve with scores of a call given the metadata. So if the score says 100% for a call, the call is considered to be fraud. To deploy the system in real time, whenever a call is made, the customer credentials and the call metadata is sent to an API gateway again. This time, there is another Lambda function that will authenticate the customer through the DynamoDB. If the customer credentials are correct and the customer is registered with the company, the request is acknowledged and sent to another Lambda function that will invoke the SageMaker endpoint to make predictions. So the SageMaker endpoint will give a score from 0 to 100. So if there is a 70% chance that the call is fraud, the score is sent back to the customer through API gateway, and this all works in milliseconds. So if the score is high enough, the customer can take steps to improve its security. Now let's take a look at another case study which is about contact service center. So this case study is using a lot of AWS services such as Amazon Transcribe, Amazon Comprehend, Amazon Athena, QuickSight, etc. But it starts by Amazon Connect. So Amazon Connect is a self-service cloud-based contact center service that makes it easier for any business to deliver better customer services. So Amazon Connect can record calls between customers and agents. Now, in order to analyze the customer sentiment during the call, first of all the past jobs and calling records should be found and submitted to S3. Once it has enough data uploaded, we can call a Lambda function, and AWS step function creates a transcribe job. So we will keep on checking for transcribe jobs on Amazon Transcribe. Once the job is completed, the text transcripts are stored back into S3. Now, the next step is to create a sentiment analysis job using Amazon Comprehend. Comprehend extracts key phrases and sentiment from the transcripts. When the job is completed, the data is again sent to S3. Later on, Amazon QuickSight provides a dashboard to view the recordings, extracted sentiment, and key phrases for caller and agent interaction. Once we have a lot of data, we can retrain our Amazon Transcribe and Comprehend models, and we can use AWS Glue with Amazon Athena to analyze our big data. Amazon Athena is basically a serverless query service which provides an interactive way to query and analyze our big data. And since we have a lot of jobs running and we have a lot of data, so we cannot keep an eye on the jobs, so we can use Amazon SNS to notify us whenever the job is completed. In this course, we took a dive into AI and machine learning services provided by AWS. We considered the features and usage of Amazon Comprehend, Kendra, and Transcribe. We also worked with Amazon Poly, Rekognition, and Personalize and learned their possible use cases. Amazon Lex, Amazon Forecast, and few other AI ML services were also touched. We analyzed a few case studies to explore the usage of these ML services with the other AWS services. Next up, we have problem formulation and data collection.